OCR A, A-level physics. This is the second video on nuclear physics. So at CERN in Geneva, they've got this massive particle accelerator. And basically what they do is they accelerate protons so that they're going ridiculously fast in opposite directions. Then they smash them into each other. And what happens is that their energy is converted into mass, and you get huge amounts of all kinds of weird particles are created. Okay, why are scientists doing this? And basically they want to know what different kinds of particles are possible. Yeah, what different kind of Lego bricks is everything made out of? And our model at the moment is called the standard model. Now, you do not need to know all of this. I'll go through what you need to know for OCR A. So, first of all, you've got your hadrons. Now, hadrons are like heavy. They're like protons and neutrons. There's loads of other different ones, by the way. But hadrons are made of quarks. Okay? The quarks that we need to know up and we need to know down. And you need to know that there's one called strange. You don't need charm or top or bottom. So there's up and down and strange. Protons are made of three quarks. Up, a proton is up, up, down. A neutron is up, down, down. Okay. Hadrons feel the strong nuclear force, which we talked about in the last video. There's also something called the weak nuclear force, and they feel that as well. The weak nuclear force is involved in beta decay. I'm going to talk loads about quarks later on. Leptons. Hadrons are heavy, leptons are light. Yeah, remember that. Leptons are light. The leptons that we need to know are electrons and neutrinos. So there's electrons there and electron neutrinos. We don't need to know muons, we don't need to know tauons, and they've got their own types of neutrino as well. So leptons are light. Leptons just feel the weak nuclear force, yeah, not the strong. And again, I'll talk a bit more about leptons in another video as well. Bosons, not really. Bosons are charge carriers in kind of quantum electrodynamics, etc. They carry forces between particles. We don't need to know anything about bosons. Sure, you've heard of some of them. Neutrinos, a little bit about neutrinos. Yes, neutrino, it means little neutral one. Yeah, neutrino. They're produced in beta decay, as we shall see. They have a tiny, 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 tiny mass. They are neutral. They travel at almost the speed of light. The sun produces a huge amount of them, but the chance of them interacting with anything is very, very small. Because they are neutral, because they travel so quickly, the chances of them interacting is very, very, very small. Okay, to give you an idea of how much the sun produces, if you hold out your thumb towards the sun, then more than 50 billion neutrinos from the sun go through your thumb every second, and you don't notice. Now, for every type of particle, there's an antiparticle, and it has the same mass, but it's got opposite charge, and it's made of antimatter. So what is antimatter? You've got matter and you've got antimatter. If you create matter, you have to create antimatter as well. If matter and antimatter get together, they cancel each other out and it produces lots of energy. Our universe, as far as we know, is made of matter. Yes, just after the universe was created, apparently, there was lots of matter and antimatter, and there was lots and lots of cancelling out, and matter won. Yes, although I'm sure if it lost, it wouldn't have been called matter. But anyway, so matter and antimatter. Now in the universe, there's only tiny, tiny amounts of antimatter, and they don't last for very long. Okay, so don't panic. But there's electrons and there are positrons. protons, antiprotons, antineutrons, and antineutrinos as well. Okay, so our universe, as far as we know, is almost all matter. Some radioactive decays produce little bits of antimatter like positrons, but they don't last very long, because as soon as that positron hits an electron, then they annihilate each other and you get a couple of gamma photons given off.